Section 2.8 Vertical Angles. The objective of this section is to recognize opposite rays and recognize vertical angles. And this is in part 1 introduction. It says opposite rays. AB, and AC are opposite rays. ED and EF are opposite rays. EG and EH are also opposite rays. The definition of opposite rays are two collinear rays that have a common endpoint and extend in different directions. Some pairs of rays that are not opposite rays are shown below. JK and MO are not parts of the same line. PT, and RS are not opposite since they do not have a common endpoint. Vertical angles. Whenever two lines intersect, two pairs of angles are formed. The definition of a vertical angle is two angles are vertical angles if the rays forming the sides of one and the rays forming the sides of the other are opposite rays. Angle 1 and angle 2 are vertical angles, and angle 3 and angle 4 are vertical angles. Are angle 3 and angle 2 vertical angles? How do vertical angles compare in size? Theorem 18 says vertical angles are congruent. Problem 1. We are given that angle 2 is congruent to angle 3. We need to prove that angle 1 is congruent to angle 3. We are given that angle 2 is congruent to angle 3. And since angle 1 is congruent to angle 2 because vertical angles are congruent, that means angle 1 is congruent to angle 3 because if angles are congruent to the same angle, they are congruent, which is this transitive property. Problem 3, we are given that the measure of angle 4 is equal to 2x plus 5, and the measure of angle 5 is x plus 30. We need to find the measure of angle 4. Our solution is 2x plus 5 is equal to x plus 30. After subtracting the 5 and subtracting the x, we know that x is equal to 25. Therefore, the measure of angle 4 is 2 times 25 plus 5, or 55.
Chapter 3.1 What are congruent figures? After studying this section, you should be able to understand the concept of congruent figures and accurately identify the corresponding parts of figures. Although you learn a bit about the art of proof in chapters 1 and 2, you may still be uneasy about proof. However, you'll find your confidence growing as you work with triangles in this chapter. What you discover about congruent triangles will help you understand the characteristics of the other geometric figures you'll meet in your studies. In general, two geometric figures are congruent if one of them could be placed on top of the other and fit exactly, point for point, side for side, and angle for angle. Congruent figures have the same size and shape. Every triangle has 6 parts, 3 angles, and 3 sides. When you say that triangle ABC is congruent to triangle FED, we mean that all of their angles and sides are congruent. The definition of a congruent angle is that all pairs of corresponding parts are congruent. With the statement triangle ABC is congruent to triangle DEF be correct? The answer is no, because corresponding letters must match in the correspondence. So C, A and F, B and E, and C and D. Congruent polygons means that all pairs of the corresponding parts are congruent. Notice that triangle KET is a reflection of triangle KIT over line KT. Angle I reflects on the angle E, angle 1 reflects on the angle 2, and angle 3 reflects on the angle 4. Line KI reflects on the line KE, and line IT reflects on the line ET over here. So they're congruent. Here's the postulate. Any segment or angle is congruent to itself, which is a reflexive property. In the following 2 problems, try to justify each conclusion with one of the properties presented in Chapter 2 and in this section. Here's our given. M and N are midpoints. Line DC is congruent to line AB, and line AB is congruent to line DB. And angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Here's what we have to conclude. Angle ADC is congruent to angle ABC. So A, D, C, A, B, C. Line C is congruent. CM is congruent to line AN. So CM and AN. Line BD is congruent to line DB. BD, DB. And line DC is congruent to line DB. DC, DB. Okay. For conclusion A, we can get this because of additional property. Because each triangle has to add up to the whole score, which is 360. For angle B, for letter B, we get division property, and for letter C, we get reflection property, which is what we just went over, and for letter D, we get transitive property, which we went over earlier in chapter 2.